So in this video we're going to talk about adding, subtracting, and multiplying complex numbers or imaginary numbers. Remember, imaginary numbers come from when you square root a negative, like -9 would actually be 3, but we put an I because of the negative part. To be clear, I is the imaginary unit and it just stands for the square root of -1. These are not real numbers. They are imaginary, and when you combine imaginary and real numbers all together, like maybe this is what we call a complex number. Complex numbers could be real or imaginary, or both. So this is a complex number. It combines a real number and an imaginary number. The rules are pretty straightforward, and remember, since i's are really just radicals, radical properties apply, and so if I want to find the sum of these, I'll just add them up. There's nothing in front of either of these parentheses to be distributed, so I really don't need the parentheses. And then all you have to do is just combine like terms. The -7 and the 1 are like terms, that makes -6. And then the 8i minus 4i makes +4i. That's it, just combine like terms. Same thing here. Again, there's nothing in front of the parentheses, so those aren't really necessary. But 5i minus 7i makes -2i, and then the -4 just stays as it is. You can't combine imaginary stuff with real numbers. You could multiply them, but you can't add them up because they're not like terms. This has a radical and this one doesn't. This one has a subtraction, and so I need to subtract both of these. Really, I need to distribute that -1 to both of those terms. So I've got 3 minus 6i minus 4, and then plus 2i. So 3 minus 4 is -1, and -6i plus 2i is, whoops, that's negative. So there we go, that's our answer there. And then for multiplication, again, it works just like you always have done with algebra stuff. You still just distribute anything in front of parentheses. So I'll distribute the -2 and get -10 minus 2i. On this one, I have a bit more distributing to do, so distribute those, distribute to those. -2 times 5 is -10. -2 times I is -2i, then 20i, and lastly, be careful here, 4i times I is 4i squared. And we're going to replace that in a second. Okay, -2i plus 20i makes 18i. The last thing that I need to do is actually, this I squared is kind of interesting because remember, I is, by definition, the square root of -1. If I square it, what do I get? Well, the square root and squared just cancel out, and I'm actually just left with -1. So anytime you have I squared, you can just replace it with -1 because that's what it is. So here, since I have an I squared, I'm going to ditch that and put in a -1. It's still being multiplied by the 4, which is going to make that be a -4. Don't add them, they're being multiplied. So now I've got all of this. And now these are like terms. So -10 minus 4 is -14. And that is my final answer. So basically, anytime you have an I squared, just replace it with a -1. Be careful because it's easy to get adding and multiplying mixed up sometimes. So for example, let's say I'm working on this problem and I'm like, oh, 5 plus 8 is 13, and 12i minus 9i makes 3i. What was my mistake there? The mistake is they were written right next to each other, so you needed to multiply, not add. So just be careful and look at what operation is happening before you jump to any sort of work. Yeah, so these all look very similar, but it's a different process. These you just combine like terms. This one, the negative needs to be distributed, and on this one, both of those need to be distributed. All right, I just want to show you, I gets kind of interesting. So we all know that I is just I, it's the square root of -1. And we just talked about I squared is -1 if we simplify it. Well, what is I cubed? Well, that would be I squared times an extra I, and we already know I squared is -1, so it's -1 times I, which would really just be -I. Let's keep going. What would I to the 4th be? Well, it would be this times another I, or we could also think of this as I squared times I squared, which would make 4. And again, we know I squareds are -1, so that would be -1 times -1, which is +1. So I to the 4th is actually just 1. Now let's do I to the 5th, which would be I to the 4th times an extra I. And we just said I to the 4th is 1, so it's 1 times I, which is just plain old I. Then I'll do I to the 6th, which is I to the 5th times an extra I. And I to the 5th is basically just I, and so it's I times I, which is I squared, which is -1. So if you keep this going, you'll actually see that this pattern continues every 4 iterations. So you get I, -1, -I, +1, I, -1, the next one would be -I, and then +1. It's basically going I1, 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 but you're changing to negative every now and then. So it's just kind of a cool pattern. So for example, in a problem like this, we got 6 times I squared times I times 2I times I. So that would be 6 times 2 is 12. And then how many i's are there? 2, 3, 4, 5. So if you remember what I to the 5th is, you could just replace it. Or you could break it into something that you do remember. Maybe you remember what I to the 4th is. Or if all else fails, just break it into I squareds. We know I squared is -1, so we've got 2, 4, 5 i's here, and so that would be 12 times -1 times -1 times an extra I, and -1 times -1 is just +1. So the answer is 12i. All right, also I do want to mention, I'm not going to do this problem, but sometimes imaginary numbers are represented with z's or complex numbers. So if you ever see something like this, it's just giving them a name.